Hello, good evening, my dear friends. Good evening. Welcome to GATE Academy Global, India's largest online platform for GATE and ESE, my dear friends. So, good evening. Welcome, my dear friends. If anybody did not subscribe to our channel, please subscribe, my dear friends, and also share our session as much as possible to your groups and your friends wherever it is possible through all your medias. Please try to share our session information so that maximum people can enjoy power system, my dear friends. Okay, yes, today is going to be stability. I am starting. Don't worry, aram se relax, just relax. I am here, don't fear, relax. My dear friends, first of all, good evening to all. Tanjeem, good evening. Suresh, good evening. Lalit, good evening. Karthik, good evening. Akash Mishra, good evening. Yesh, good evening. Lakshmi, good evening. Sandeep, good evening. Srinath, good evening. Yes, let's rock the stability. Yes, Ashwini Kumar, good evening. Yes, Lakshmi, don't worry. Today I am going to start the stability topic. Don't worry about it. Now I am going to start stability topic. But please confirm once, my dear friends, whether my voice is clearly audible to each and every person or not. And also please confirm once, am I clearly visible or not? Means look like handsome or not? Means just I am kidding, my dear friends. Am I clearly visible or not? And also please confirm the screen is clearly visible or not. Varun sir, good evening. Srinath, okay, all clear. Then let us start the session, my dear friends, without any time waste. We know, dear friends, in control system also we are going to be study stability. Control system, there is a stability topic. Control system, there is a stability topic. And in power system also there is a stability topic. The ultimate aim of both the subjects is going to be remain same, but the way that we are handling stability concept in both the subjects is going to be different, my dear friends. Okay, let me start the session without any time delay. I hope everybody is good. Hi sir, good evening. Varun sir, so much do share everyone. Sir is the best teacher of my God. Varun sir, really it is big respect to me. Bow to you sir from my side. I am very much thankful, Varun sir. Varun sir is going to be king of thermodynamics and fluid mechanics from mechanical, my dear friends. Sir is one of my best friend. Since last 5 years we are teaching together, my dear friends, across the country. Please share mechanical to your mechanical friends also. Please share about Varun sir classes. That is going to be much helpful to mechanical students, my dear friends. Thank you, Varun sir, for your respect. Same from my side towards you. Kalyani, good evening. Okay, my dear friends, let's start the session without any time delay. In control system stability, definition is for any LTI system. Tell me what is the practical example of LTI system. That is very important. Practical examples are going to be more important in any subject, so that as an engineer we can reach towards the destination. Am I correct? Engineer means has to think everything practically, my dear friends. Any LTI system, if you are applying bounded input, BIBO input, when you are applying bounded input to the LTI system, if output of LTI system also bounded, then the system is going to be said to be stable system, my dear friends. In case of control system, LTI system means linear time invariant system, my dear friends. What is linear time invariant system? You know, piano is going to be linear time invariant system, my dear friends. The piano who are playing, like in Bahubali movie, the music director Keeravan is playing with the piano, right? Whenever he is going to press that buttons, then only that is going to be played, otherwise it is not going to be played. That means whatever the input you are applying, output also coming according to that. Therefore the piano is going to be linear time invariant system, my dear friends, in case of control system. In case of control system, definition of stability is for any LTI system, if bounded input is applied, output of the system is bounded, then the system is going to be said to be stable system. But we are not discussing right now control system stability. We are going to discuss right now power system stability, my dear friends. This is very important. Dear friends, what is the main aim of our power system network? What is the main aim or target in case of power system stability? That is very important. The main aim and target in case of power system stability is going to be the existing power system should remain in stable the existing power system should remain in stable while it is delivering real power or useful power to the load point from the synchronous generator, even though there are certain disturbances in power system network, is going to be our ultimate goal or ultimate target or ultimate aim in power system as an electrical engineer. Once again I am repeating, the existing power system, tell me what will be the existing power system? Synchronous generator is connected to bus bar, my dear friends, then connected to step up transformer, then connected to bus bar, then connected to transmission line, then bus bar, then step down transformer connected to bus bar, then load, my dear friends. This is going to be existing power system, engineers. What is input to the generator, my dear friends? The input to the generator is going to be shaft power. The output power of the single line diagram is going to be electrical power. I can say for synchronous generator, input is going to be mechanical power or shaft power, and output is going to be electrical power or useful power or real power, my dear friends. We can say the electrical power is also called as useful power or active power or real power, my dear friends. Now tell me, my dear friends, what is our target in power system stability? The existing power system. This is existing power system. That means from the generating plant up to the load point, means up to Bangalore city or up to entire Indian power system, up to the consumers. From generating plant, that is from remote generating plant up to end of the consumer, entire this power system is going to be remain in stable while the synchronous generator is delivering useful power to the load point, even though there are certain disturbances in power system, is going to be our ultimate target, our ultimate goal or ultimate aim in the power system, my dear friends. This is going to be the first point. So please try to understand what is the aim or target in power system. Already I have explained, my dear friends. Second point is the concept of stability in power system. The concept of stability in power system is purely associated with synchronous machine, is not at all associated with asynchronous machine. Once again I am repeating, the concept of stability in power system is purely associated with synchronous machine but not associated with any other machine, my dear friends. Let us assume this is going to be induction generator. Let I am assuming the power we are generating in the power plant with the help of induction generator. Dear friends, in machines class you studied induction generator also called as asynchronous generator. Why? Because rotation of rotor and rotation of stator flux is going to be not equal. There will be a slip is present between both the speeds. That is the reason why induction generator is also called as asynchronous generator. No doubt most of the loads in power system at the consumer side or load side is going to be inductive load, my dear friends. When there is an inductive load, definitely that is called as asynchronous load, my dear friends. Tell me, power driven by the load is in asynchronous manner because of inductive load. Power generation at the generating stand is going to be in asynchronous manner. Therefore, the transmission of power in the transmission line also going to be asynchronous power transmission. Which transmission is? Asynchronous power transmission. This is very important, my dear friends. Asynchronous power transmission. Tell me, is this system is going to have any stability criteria concept? No, definitely this system we do not have any stability criteria because generation of power is going to be in asynchronous manner. Power driven by the load also asynchronous manner. Majorly the power which is transmitted in the transmission line is asynchronous manner. Therefore, this power system network does not have any stability criteria, my dear friends. Srinath, sir, why we are not considering reactive power? Oh my god, basic level question. Reactive power already I have explained, Srinath. Maybe first class, beginning class itself I have explained. First two videos I have clearly explained what is real power, what is reactive power. Real power is used to produce the torque. Reactive power is used to convert the torque into rotating angle so that the power whatever we are going to consume in the machine in order to rotate the machine to convert active power into torque is going to be called as reactive power, my dear friends. Always we are going to discuss useful power with respect to the load point but not reactive power, my dear friends. Srinath, this is the basic level question. That is the reason why if basic classes everybody understood, then only can understand power system class, right? So I hope everybody understand real power is going to be ultimate target but not going to be reactive power, my dear friends. Tanzim, why stability concept is not present in the induction machine? Very good question. Tanzim, I will explain this question. This is also one of the interview question, my dear friends. Both questions are very good, but for Srinath question already I have completed answer in basics. Now, in this case I am going to explain right now. Tanjim asked very good question. Why stability concept is not related with induction generator? Dear friends, for stability and economical reasons, always in the power plant or in generating station, we need to connect more than one generator in parallel. Whenever we want to connect one generator in parallel, we need to check their polarity and their phase sequence, and their one is going to be voltage polarity and then going to be phase sequence is going to be more important, my dear friends. And also all the machines must maintain at constant frequency, right? That we are going to understand. What Tanjim you are going to understand soon about why we are not going to be discussing induction machine with respect to stability. The stability concept is associated with why synchronous machine slowly. That means when we are going forward direction, we will understand each and every point, my dear friends. Okay, let me start right now. Listen, this power system network does not have any stability criteria. Why? Because generation of power is going to be in asynchronous manner, power driven by the load also asynchronous manner, so that the transmission of power also going to be in asynchronous manner. Therefore, the above system does not have any stability criteria, my dear friends. The concept of stability in power system is purely associated with synchronous machine, but not going to be induction machine, my dear friends. The concept of stability is associated purely with synchronous machine, not is going to be asynchronous machine. Therefore, right now I am going to use synchronous generator. Whenever we are generating power with the help of synchronous generator, my dear friends, rotation of rotor flux, rotation of stator flux, both are maintaining at same speed and same frequency. Therefore, we can connect multiple generators in parallel. Whenever there is a multiple generators in parallel, then we can discuss stability concept. Dear friends, in case of induction machine, parallel operation is not possible. Tanjim, I started explaining answers for your question. In case of induction generator, we are unable to connect number of generators in parallel. Why? Because they are operating at different speeds and different frequencies, my dear friends. Therefore, we are unable to connect number of generators in parallel in case of induction machine. Whenever parallel operation is not possible in case of induction machines, automatically there is no concept of stability. That means when there is only one machine, there is no discussion about stability. When there is more than one machine, definitely all the machines are going to be dealing with stability criteria. Like, listen friend, I am only explaining the class and I am only listening the class, which means there is no stability concept required with respect to me alone. Now you are listening the class when I am teaching the class, my dear friends. Definitely there is a synchronism is required between you and me, because we are more people present here. Therefore, the stability concept is associated with only when then there is only more than one machine is present in power system. Otherwise, there is no concept of stability in power system, my dear friends. I can say, my dear engineers, stability concept is associated purely when system is having synchronous generator rather than asynchronous generator. Now tell me, when synchronous generator is present in the power plant, automatically the transmission of power also going to be in a synchronous manner, my dear friends. The transmission of power is also going to be synchronous manner. Therefore, automatically this system is having stability criteria, my dear friends. No doubt, load is going to be always inductive load or asynchronous load, because most of the loads are going to be inductive loads. Whenever most of the loads are inductive loads, therefore there is no problem with inductive load. Load is going to be always asynchronous load, but generation is going to be in synchronous manner. Automatically these generators can maintain synchronism with externally connected transmission lines are called tie lines. Therefore, this system is having stability criteria. Please do understand, my dear friends, the concept of stability purely associated with synchronous machine, but not going to be asynchronous machine. Why? Because when synchronous machine is there, we can connect more number of generators are in parallel. What will be the advantage? Soon we will understand. And also it can maintain synchronism with the transmission lines. Automatically maximum power or maximum useful power or real power is transmitted to the load point. Therefore, the above system is dealing with stability criteria. Please do remember, my dear friends, the concept of stability in power system is purely associated with synchronous generator, but not going to be induction generator. First point is clear. Now, the stability concept is always continuously, that means the stability of the machines or the stability of the power system always continuously monitoring from control rooms in the power system. Now, the control rooms or control centers are of two types. Once again I am repeating, the stability of the power system network continuously monitoring by electrical engineers from the control rooms or control centers, my dear friends. Tell me, what are the control rooms or control centers present in the power system so that the engineers can be monitored from there. Now dear friends, there are two control centers or two control rooms. One is going to be SLDC, one is going to be SLDC. What is SLDC? Can anybody give the answer? And other is going to be RLDC, my dear friends. SLDC is nothing but State Load Dispatch Center. SLDC is nothing but State Load Dispatch Center, my dear friends. This is one control center from the state government, and second RLDC is nothing but Regional Node Dispatch Center. This is going to be another control room or another control center which is operating under Government of India, my dear friends. Am I correct? Now tell me, very good, Tanjim, SCADA system. Yeah, that's SCADA. That means that is one of the software that we are using in SLDC and RLDC, my dear friends. State Load Dispatch Center purely established and monitored by state transmission companies. This SLDC is purely established and monitored by state transmission companies, that is under the state government, my dear friends. The state transmission companies means, if you take Andhra Pradesh, it is going to be AP Transco. Andhra Pradesh Transco is going to be monitoring State Load Dispatch Center. That means from control center of the SLDC, always the engineers are observing the speed of rotation and frequency of supply for power system, my dear friends. Am I correct? And second one, RLDC, Regional Load Dispatch Center, dear friends, it is established. E and M means established and monitored by PGCL. PGCL means Power Grid Corporation of India Limited, which is working under Government of India, my dear friends. Which is working under Government of India, right? These are the control centers present in the power system. From these control centers, always electrical engineers, that means tomorrow if you are going to select either Power Grid Corporation of India Limited or else AP Transco, any electrical engineer, if you are selected for AP Transco government, that means transmission company government in Andhra Pradesh, or else any person who is selected for Power Grid Corporation of India Limited, from next year onwards definitely you are also going to monitor the stability of a power system from the control centers. Now what you are monitoring from the control centers in the power system is going to be either speed of rotation or frequency of supply. Continuously the engineers are monitoring. Based on that they can feel or they can explain power system is stable or not. Okay, now once again I am repeating, the stability in a power system is always continuously monitoring from the control rooms or control centers. The control rooms or control centers are going to be State Load Dispatch Center, which was established and monitored by state transmission companies, and Regional Load Dispatch Center, it is established and monitored by Power Grid Corporation of India Limited, my dear friends. Okay. Mayur Thakodra, sir, how many RLDC in India can we know? That is depends upon the number of power grid centers, my dear friends. Just Google it, you can find that answer. There is no need to worry about this. Okay. At the end of the class, I will explain if you require, but general discussion. But let me continue the sequence, my dear friends. Let us concentrate now. I am going to start the discussion. Listen, dear friends. With respect to power system stability, the engineers are always monitoring from control centers two parameters. One is going to be speed of rotation, second is going to be frequency of supply. That means how engineers are monitoring the stability of a control system from the control center is, one is going to be they are checking always speed of rotation, second is going to be frequency of power supply, my dear friends. Listen, dear friends, the stability in power system is monitoring by two parameters. One is going to be speed of rotation, second is going to be frequency of power supply. Speed of rotation is represented by N, and second is going to be frequency of power supply. The frequency of power supply is represented by F. Okay. Now please do understand one important thing, my dear friends. We know, dear friends, speed N is equal to 120 into F divided by P, where F is frequency, P is number of poles, N is going to be speed of rotation, my dear friends. Tell me, when number of poles are changes, my dear friends, frequency is going to be constant, there is no change in frequency. When number of poles are changes in power system, definitely speed of rotation also changes, but frequency of power supply is going to be constant. Whether poles are 2 or 4 or 6 or 8, whatever the number of poles are changing continuously, The speed of rotation is going to be changes, but frequency of power supply is going to be remains constant. I can say, my dear friends, frequency of power supply will be taken as main parameter to monitor the stability by the electrical engineers in the control center rather than or instead of speed as main parameter. Why? Because when number of poles are changing, speed of rotation of the system is changing, but frequency is going to be remains constant, my dear friends. Therefore, frequency of power supply will be taken as reference parameter to monitor the stability from the control centers, but not speed of rotation, my dear friends. Please confirm once. Everybody understanding the concepts or not? Please confirm once, my dear friends. Please confirm once in the chat box. Everybody understanding the concepts or not? Attendance is more important. If you are really enjoying the power system stability class, please press the like button. Please like the session and also share as much as possible. Tell me, everybody understanding the concepts? Monitoring frequency or monitoring speed, both are same na sir, as n is equal to 120 by f. Yes, but already explained, Tanji. When poles of the machine is changing, speed of rotation is going to be changes, but frequency of power supply is going to be constant. Therefore, frequency will be taken as main parameter but not speed of rotation. Why? Because number of poles are changing, speed of rotation also changes. Many people are thinking stability means speed is constant. No, when number of poles are changing, speed of rotation also changes, but frequency of all the poles is going to be remains constant. Therefore, frequency is going to be taken as main parameter to monitor the stability from the control center, but speed of rotation of power system is not going to be taken as reference to monitor stability in power system, my dear friends. Am I correct? Now tell me, my important point is the frequency of power supply is depends upon input to the synchronous generator and also depends upon electrical output of the synchronous generator. That means the frequency of power supply and speed of rotation in power system is depends on two parameters. One is input power of the synchronous generator, other is output power of the synchronous generator. That means the speed of rotation or frequency of power supply in case of power system is does depends on two parameters. One is input power to the synchronous generator, that is shaft power, and output power of the synchronous generator, that is electrical power, my dear friends. Okay, listen friends, I am going to discuss right now initial conditions. I am going to discuss right now initial conditions. Please do understand concepts very clearly. This is synchronous generator, let us assume connected to bus bar. This is mechanical active elements are there. What is input power to the synchronous generator is going to be shaft power. P suffix S is going to be called shaft power, which is also called as mechanical power or steam input. And output power of synchronous generator is going to be electrical power. What is initial conditions in power system is, it is assumed that output power is equivalent to input power, that is electrical power or real power or active power is equivalent to steam input or shaft power or mechanical power. Then power losses is going to be input power minus output power, that is shaft power minus electrical power. When both the powers are equal, then power losses are equal to 0. When power losses are equal to 0, tell me dear friend, speed of the machine is going to be synchronous speed. When speed of the machine is going to be synchronous speed, automatically angular speed is omega equal to omega s, linear speed n is equal to ns, and frequency is going to be constant, that is 50 Hz, my dear friends. I can say when electrical power is equal to shaft power, these are the initial conditions that we have to assume before losing the stability. That means before losing the stability we have to assume electrical power is equal to shaft power. When both the powers are equal, power losses is equal to 0. When power losses equal to 0, the speed is going to be synchronous speed, frequency is going to be 50 Hz, which is constant, and load angle delta naught also constant, my dear friends. Please concentrate more effectively. Each and every point is going to be very much important in case of stability, my dear friends. Listen, the synchronous generator will have two axes. One is going to be what? Please reply in the chat box. This is very important. Synchronous generator will have two axes. One is going to be reference rotating axis. One is going to be reference rotating axis and other is going to be rotor rotating axis. Other is going to be rotor rotating axis. In case of synchronous generator, rotor rotating axis is ahead of the reference rotating axis, and the angle between these two is going to be delta naught. This delta naught is going to be constant initially when electrical power equal to shaft power, my dear engineers. Now tell me, this load delta naught is called as load angle, which is also called as power angle, which is also called as torque angle, my dear friends. Many times this question was repeated in the GATE exam or IES exam or any central government, state government, PSUs, my dear friends. They are asking question, the delta is the angle between what and what? The load angle delta or torque angle or delta, power angle delta. Delta is the angle between what and what? Is going to be angle between rotor rotating axis or rotor rotating flux to the reference rotating flux. My dear friends, some of the time reference rotating flux is also called as synchronously rotating axis. Sometimes reference rotating axis is also called as synchronously rotating axis, my dear friends. Therefore, please do remember this concept. The load angle delta naught is going to be the angle between synchronously rotating axis to the rotor rotating axis or rotor rotating axis to the reference rotating axis. I can say delta is the angle between rotor rotating axis to the synchronously rotating axis, my dear friends. In case of electrical machines, you have studied the delta is going to be angle between internal excitation voltage of generator and terminal voltage of the generator, my dear friends. This is many times this question is repeated. In case of machines, you have studied the delta is the angle between E and V, where E is and V are due to this concept. That means the initial concept and practical concept of synchronous generator is going to be based on this. This is going to be rotor rotating axis, this is reference rotating axis. Reference rotating axis is also called as synchronously rotating axis. Many exams I have seen this. The load angle delta is called as angle between reference rotating axis to the rotor rotating axis, which is also called as reference rotating axis is also called as synchronously rotating axis, my dear friends. My dear friends, now question is, this is the discussion with respect to synchronous generator or synchronous motor. Please comment in the comment section. This is the discussion so far we have made with respect to synchronous generator. In case of synchronous motor, my dear friends, this is synchronous motor. Dear friends, input power is going to be, what is input power in case of synchronous motor? Is electrical power. Output power of the synchronous motor is going to be mechanical power or shaft power. I can say it is quite opposite to or mirror image of synchronous generator, my dear friends. But in case of synchronous motor, reference rotating axis is going to be remains fixed. Reference rotating axis is going to be remains fixed, but rotor rotating axis is lagging behind the reference rotating axis. This is rotor rotating axis. Here also the angle delta in case of synchronous motor also same, that is going to be constant initially, that is mechanical power is same as electrical power or output power is equal to electrical power. There is no power losses. When there is no power losses, speed is going to be synchronous speed, frequency is going to be constant and load angle is going to be constant. But load angle here also it is the angle between reference rotating axis to the rotor rotating axis. But in case of synchronous motor, rotor rotating axis is lagging behind the reference rotating axis, like mirror image of synchronous generator, my dear friends. These are very important in order to understand the power system. Without this, we can't able to understand stability concept, my dear friends. Tell me, everybody catching my concept, please? Sir, load angle, torque angle, power angle, all are same, Lakshmi. Load angle, torque angle, power angle, all are is going to be delta only. The delta is called as load angle or power angle or torque angle. Everything will be same. Tanzim, rotor axis. Sandeep Saha, reference and rotor rotating axis. Very good. So many people are replied. Mayur Thakora also replied. Tanzim also replied E and V. Very good. Jagadish, sir, why delta is greater than 90 degrees? Alternator lost the synchronism. Very good. Jagadish, please stay tuned because you asked advanced question. Still we did not reach that much level in the power system. So please wait for some more time. We will discuss why delta is going to be more than 90 degrees. Synchronous generator is going to lose the synchronism. That is in case of only steady state stability limit, but not in transient stability limit. Jagadish, stay tuned. For better understanding of power system, wait for some more time, my dear friends. Okay, this is going to be the basic level discussion. Now tell me, as we are discussing stability concept with synchronous machine, Therefore, we have discussed about synchronous generator and synchronous motor, my dear friends. Now tell me, initial conditions is going to be electrical power is same as shaft power, electrical power is going to be output power in case of generator, and input power to the generator is going to be shaft power, then power loss is equal to 0, synchronous speed is equal to synchronous speed, frequency is going to be 50 Hz and angle is going to be constant. These parameters will be taken as reference to understand the power system, my dear friends. These parameters is going to be taking reference to understand power system. These are going to be reference parameters to understand power system. Now, I have explained what is a target in power system. I have explained stability concept is associated with which machine. I have explained third, I have explained how to control or how to monitor the stability in power system and from where we have to monitor and what are the parameters that we have to take into condition to monitor the power system stability and what will be the initial conditions of power system. Everything I have explained so far, my dear friends. Now I am going to explain what is definition of stability. What is definition of stability? Please don't give definition of stability is if you are applying bounded input to the LTI system, sir, output is going to be bounded, then system is called a stable system. If bounded input is applied to LTI system, your output is unbounded, then system is unstable system. This is not a control system, my dear friends. This is powerful power system. The definition of power system stability I am going to explain right now. Listen. Already in transmission line basics I have explained the rotor angle of the synchronous generator, mainly influenced by characteristics of the transmission line rather than characteristics of the transformer. Therefore, for a while we are ignoring transformers. Already we discussed same concept in the transmission line, my dear friends. Now tell me, why we ignore the transformer? Why? Because the rotor angle of the synchronous generator mainly influenced by characteristics of the transmission line rather than characteristics of the transformer. Why? Because faults are more common in the transmission line. Therefore, the load angle delta changes as and when fault occurs in the transmission line because faults are more common in the transmission line. That is the reason why we have ignored the transformers, my dear friends. And also I have explained one more point. For stability reasons, sending end voltage angle is going to be same as generator angle. Already these concepts very clearly I have explained in case of transmission line, my dear friends. Sending end angle is same as generator angle and voltage at the receiving end is going to be VR and angle at the receiving end is going to be 0 and this is IR, this is IS, my dear friends. Very clearly I have explained all these things. Please do remember, in power system stability, every year the IIT professors are going to be playing with the students by giving one small concept here. Let me explain what is that concept here. Dear friends, to transmit the power from generating station to the load center, always angle at the generating station should be more than angle at the receiving end. Now tell me, delta is going to be more than 0 degrees, then only we can transmit power from generator to the load point. This is the first point. In order to transmit power, once again I am repeating, many questions are coming from this topic, that is the reason why I am going to explain once again, my dear friends. In order to transmit power from the generating station to the load center, always angle at the generating station must be more than angle at the receiving end. Dear friends, what is the angle at the receiving end is going to be 0 degrees. Now compared to this angle at the sending end should be more. That is the reason why I have selected it as plus delta, not minus delta. Sometimes, my dear friends, very good. I am really appreciating you given the beautiful definition, my dear friends, but please focus here. I need to explain so many concepts with respect to gate level. Dear friends, sometime in the gate question paper, every year there is a gate question like this. Every year on this point there is a gate question. Please concentrate here. Sometimes in the gate question paper, they will give, my dear friends, this is going to be sending end voltage as V1, angle is 0 degrees. Tell me, receiving end voltage is given as V2 and angle is given delta. This is going to be the blunder mistake or simple mistake IIT professors are doing. Are you thinking like this? No, that is wrong. IIT professors are checking the student depth or student mentality here, how they will commit the mistake they required. That is the reason why they want to give this kind of question. That means they are testing your patience, they are testing your knowledge. Dear friends, just now I have explained, angle at the sending end must be more than angle at the receiving end, then only power can flow from generator to the load point. Right now, if you observe here, angle at the sending end is given as 0 degrees, angle at the receiving end is given as delta. Tell me, delta is more than 0 degrees means power flow is from load point to the source point. That means my home is supplying power to the generating plant. Is really big joke in power system, my dear engineers. Now tell me, what is the corrections is required here? Tanzim, power absorbed by the generator, but generator power will not absorb, that is going to be sure. Always generator is going to generate the power, but not going to be absorb the power. Now tell me, Tiruvasangam, what is the voltage swing? That we have to wait. Tiruvasangam, we have to wait up to transient stability, I will explain. Ashwini Kumar is given superb answer. Aditya Kumar, delta must be negative for this case. Very good, very good. Ashwini Kumar also given delta is negative, sir. Superb, my dear friends. Now tell me, my dear friends, whenever they given voltage at the sending end angle is going to be 0 degrees, in order to transmit the power from the generating station to the load center, this delta should be less than 0 degrees. Tell me when the delta is going to be less than 0 degrees, when you consider the delta value is going to be negative sign. That means we have to take it is minus delta while solving questions. Otherwise, definitely your answer is going to be somewhere in the Ganga river, my dear friends. Negative marks is going to be increased. Dear friends, this is going to be ultimate topic. Please concentrate more, then only you are able to catch the power system. Once again I am repeating, angle at the receiving end, if it is given more than 0 degrees, that is more than sending end angle, that means that is against the concept. In order to make the power flow, always angle at the sending end must be more than angle at the receiving end. If it is given 0 degrees, if it is given delta, that means the load angle should be less than always 0 degrees. That is possible when you take it as a negative value. Therefore, angle delta is going to be taken as negative, then only it is going to be less than 0 degrees. Power can flow from generator to the load point, my dear friends. This is very, very important. Please focus on this if anytime they are giving questions like this. Okay, now listen. This basic point is completed. Now I am going to start the definition of stability. What is the definition of stability? Very good. Tamjim is given, Sandeep is given, Lakshmi is given answers. Very good, my dear friends. Let me explain definition of stability. Together we will discuss right now stability definition. It is ability of synchronous generator to deliver maximum useful power or real power to the load point by maintaining synchronism with externally connected tie lines, are also called as transmission lines, is known as power system stability. Once again I am repeating, it is ability of the synchronous generator or source or at the power plant to deliver maximum useful power or real power or active power to the load point by maintaining. Tell me who are going to deliver, who are going to transmit maximum useful power to the load point, that is transmission line. Therefore, it has to be maintained synchronism with externally connected transmission lines, which is nothing but external connected transmission lines is known as stability, my dear friends. Now tell me, what is stability definition? It is ability of synchronous generator which could able to deliver maximum real power or useful power or active power to the load point by maintaining synchronism with externally connected transmission lines is known as stability. In our class, what is stability definition is, it is ability of the Vishnu Sir or it is ability of the power system faculty to deliver maximum useful content, not useless content, maximum useful content to the students by maintaining synchronism between all this external setup is known as stability, is known as stability. Please see above question. Sandeep Saha, higher angle or lower angle power flow only from inductive line, is it? Yes, inductive only. Yes, maximum loads are inductive loads, Sandeep Saha. That's the reason why we have discussed that point. Very good. Your question is good, and also your question itself is having answer. That is perfect. Sandeep, is it clear? Sandeep, is it clear? I didn't see your question because of chat is more. Okay, no problem, my dear friends. Very good. Sandeep, is it clear? Confirm once so that I can move forward direction. Now once again I am repeating stability of our class. It is the maximum, it is the ability of Vishnu Sir or ability of power system faculty should able to deliver or could able to deliver maximum useful content related to power system to the students. Means load, you are the load, I am the source. Students nothing but load, I am the source, means I am generator. Here you are going to be load by maintaining synchronization with externally connected all this setup is known as power system stability, sorry, our classroom stability, my dear friends. What is external setup? Camera and digital board system, everything has to cooperate, each and everything. Because of this setup only I am able to deliver my useful content to my dear Priya Vidyarthiyon, means my dear students, so that there will be maximum content is reaches to the load center, that is students point, so that they can get best out of best in the GATE or IES or any other kind of exam, my dear friends. I think everybody got the concept. This is going to be the stability concept. Similarly, same concept here, my dear friends. What is the same concept? It is ability of synchronous generator which could able to deliver maximum useful power to the load point by maintaining synchronization with externally connected transmission lines is known as stability. Where is Srinath? Srinath, I am explaining powerful points. Are you understanding why synchronism with synchronous machines you asked beginning, but you are not appearing in the chat box? Srinath, are you understanding my points what I have explained? Let us move forward direction, my dear friends. Stability discussion also completed. Now question is, why power system is losing the stability? Definition is also completed. Now my ultimate question is, why power system is losing the stability? Can anybody give the answer in the chat box? Can anybody give you the answer in the chat box? Why power system is losing the stability? What is the meaning of synchronizing in the transmission lines? Satish, you will understand. You will understand. Soon you will understand. Just wait for some more time. Soon you will understand, Satish. Tanjim, wah, kya baat hai sir. Yeah, thank you, my dear friends. Very good. Lalit is replied, Sandeep is replied. Very good, my dear friends. Why power system is losing the stability? The power system is losing stability because of occurrence of the fault in the transmission line, occurrence of fault in the power system, my dear friends, or else small variations at the load point due to maloperating of the switches by the consumers, or there will be sudden and large variation of the load point because of occurrence of short circuit fault in the transmission lines. Because of this, power system is going to be losing the stability. That means, very good, my dear friends, from Lalit Mahavar, every person is replied. There is going to be two reasons. There is going to be two reasons, once, dear friends. The power system is going to be losing the stability because of variations at the load point. That means, when load is going to be varies, automatically the electrical output power, electrical power also going to be vary, but due to effect of inertia or due to momentum of inertia, my dear friends, the shaft power which is supplied to generator is going to be constant, so that the electrical power is not equivalent to shaft power. Automatically synchronous generator is not maintaining synchronous speed, so that it can get either acceleration of the speed or deacceleration of the speed. By that, load angle delta changes, frequency of power supply is not equal to 50 Hz, so that the synchronous generator or entire power system is going to lose the stability. Very good, my dear friends. Superb. All people are given for tremendous response from your side. Let me repeat once again. Once again, cool manner I am explaining, but attendance is more important, my dear friends. So those who are enjoying the power system class, please share our session as much as possible to all your groups, and also attendance is more important. For that, please like the session and share as much as possible. And anybody did not subscribe, please subscribe to our Gate Academy Global channel for more updates, my dear friends. Okay, let me continue right now. One more discussion. The most uncertain thing, the most that means the most uncertainty or the most changes present in the power system is at the load point but not at the source point. That means always the variable parameter in power system is going to be load demand. Always the power system variable is going to be present at the load demand side. That means when load is going to be varies at the load point, immediately electrical power at the load point also varies, but shaft power supplying to synchronous generator with the help of prime mover and speed governor will not allow the sudden change. Automatically shaft power is going to be constant and electrical power varies, so that electrical power is not equivalent to shaft power. When electrical power is not equivalent to shaft power, power losses is not equal to 0. That means speed of the machine is not equal to synchronous speed. Frequency of power supply is not equal to 50 Hz. Load angle delta is going to be variable, right? Whenever all these things are happening in power system, automatically we can say that power system is under not stable condition, or I can say power system is lost the stability, my dear friends. Now tell me, why variations of load is occurring at the load point? That means why load is continuously variable at the load point. That is most important point. Tell me, dear friends, there are two types of variations. Tell me how many types of variations present at the load point. Can anybody give the answer? Synchronism with transmission line. Generator is synchronized with transmission line, then only it can transmit maximum power to the load point. Ashwini Kumar, Kalyani is given load variations and faults, sir. Very good, superb. Atul Singh Rajput also given answers. Very good, dear friends. Now tell me, how many types of variations of load practically possible in power system? Can anybody give the answer? How many types of variations of load practically possible in power system, my dear friends? There will be two types of variations of the load in practical power system, my dear friends. One is going to be small and gradual variation of load. One is going to be small and gradual variation of load. Second is going to be sudden and large variation of load, my dear friends. One is going to be small and gradual. Second is going to be sudden and large variation of load. Small and gradual variation of load generally, because it is happening, that means it is generally small and gradual variation of load is occurring in power system. That small and gradual variation of load in power system is occurring due to mal operation of the switches by the consumers. Because of that, there will be small disturbances present at the load side. Because of that, the variations in electrical power also very much less. Whenever the variations in electrical power is very much less, but shaft power is going to be remains constant at the generating station due to effect of inertia, then power losses P is equal to PS minus PE. The variations in electrical power is very much less. Therefore, the variations between them is almost negligible. The variation between them is almost negligible. I can say variation in speed also is going to be within the limits, and variation of angle also within the limits, that is going to be negligible, but variations in frequency is not going to be negligible. At this time, my dear friends, power system is dealing with steady state stability. Why? Because the small variations are negligible, because the small disturbances is neglected in power system. Therefore, the power system is dealing with steady state stability. Tell me, small and gradual variation of load in power system is happening each and every day, my dear friends, due to mal operation of the switches by the consumers. Therefore, the small and gradual variation of load is dealing with steady state stability. Dear friends, when there is a short circuit fault occurs in the transmission line, tell me, faults are going to be more common in the transmission line, because transmission lines are exposed to wide number of natural phenomena, my dear friends. Now tell me, when short circuit fault occurs in the transmission line, there will be large variation there will be large variations at the load point. Automatically, large variations in electrical power at the load point. That large variation in electrical power is going to be not neglected in this case, but shaft power is going to be remains constant, so that electrical power is not equivalent to shaft power. I can say power losses is going to be not negligible, it is going to be considerable, so that the variation in speed is going to be large, and variation frequency large, and variation of load angle also large. And at that time, synchronous generator is dealing with transient stability, my dear friends. Now tell me, sudden and large variation of load is occurring because of short circuit fault in the power system. Due to that, the variations in the synchronous generator is going to be very much high. At the time, we have to deal that sudden and large variation of load is going to be dealing by transient stability, my dear friends. I can say, my dear engineers, sudden and large variation of load is dealing with mechanical vibrations, is going to be dealing with mechanical vibrations. To understand that sudden and large variation of load in case of electrical power system, we have to apply principles of kinematics, that we are going to introduce engineering mechanics subject basics while discussing transient stability, my dear friends. But in case of small and gradual variation of load, the variations are going to be negligible. At the time, it does not have any mechanical vibrations. Therefore, small and gradual variation of electrical system, small and gradual variation of load is studied in terms of electrical character, but not in terms of mechanical character, my dear friends. This is very important. That means small and gradual variation of load is dealing with respect to stator field winding, my dear friends. Very important. Many interviews this question is asking. Whereas sudden and large variation of load is dealing with transient stability. At the time, we have to study the stability of transient stability of electrical power system with respect to rotor, my dear friends. This is very important. This is very important. Sir, we made lightweight rotors, then stability problem is highly minimized. Yes, there are so many techniques, Tanjim. There are so many techniques to minimize this, that means to increase the stability. There are so many techniques that is going to be powerful topic in power system. In many interviews, these questions are asking. Please, aram se, like, be patient. Aram se we will discuss what are the techniques that we have to improve the power system stability. That is going to be end of the topic, but not going to be starting of the topic. If I am opening everything right now, you will get confused, the sequence also will be missed. That's why please stay tuned, my dear friends, so that we will understand each and everything, my dear friends. Okay, now tell me, the power system is losing the stability or getting lost the stability because of variations at the load. How many types of variations at the load? Two types of variations at the load. One is small and gradual variation of load, second is sudden and large variation of load. Small and gradual variation of load is dealing with steady state stability, sudden and large variation of load deals with transient stability. The sudden and transient stability is going to be studied in terms of mechanical vibrations. For that, principles of kinematics will be introduced, and that will be studied with respect to rotor field winding of synchronous generator, whereas dynamic stability is nothing but transient stability, Lakshmi, right? Steady state stability will be studied, dear friends, with respect to stator field winding, that is studied in terms of electrical characteristics, whereas transient stability is studying in terms of mechanical characteristics, my dear friends. This is very, very important. Stay tuned how it is going to be studied with respect to stator winding and how it is going to be studied with respect to rotor winding, that we will be discussed very clearly in forward direction, my dear friends. Okay, now question is, small and gradual variation of load is more common or sudden and large variation of load is going to be more common? Please give the answers. Small and gradual variation of load is going to be more common or sudden and large variation of load is going to be more common in power system? Please give the answers. Which is going to be more common and which is going to be more severe? Which is going to be less common and which is going to be less severe in power system? Can anybody give the answer, my dear friends? Very good. Small and gradual variation of load is going to be more common, my dear friends, because every time the consumers are operating the switches in mal operation way, that is the reason why small and gradual variation of load is common each and every day power system. But occurrence of short circuit fault is very rare in power system. That is due to abnormal condition like this season, rainy season. So there will be thunders, there will be lightning strokes, and there will be huge wind flows. Automatically the trees are falling on the tree branches are falling on the transmission lines. Because of this, only short circuit fault occurring. But that means maximum time we have small and gradual variation of load. Very small time we have sudden and large variation of load, my dear friends. Am I correct? Now tell me, small and gradual variation of load is going to be more common in power system, but that is less severe. Sudden and large variation of load is going to be less common in power system, that is going to be more severe, my dear friends. Please do understand, small and gradual variation of load is going to be more common, but it is going to be less severe. Sudden and large variation of load is going to be less common, but it is more severe. Once it is occurred, that is going to be more severe, my dear friends. Small and gradual variation of load is dealing with steady state stability. Sudden and large variation of load is going to be deals with transient stability, my dear friends. I think everybody got the concept up to now. Okay, now my dear friends, I am going to discuss steady state stability, that is small and gradual variation of load. I am going to discuss steady state stability concept right now. Many gate questions are coming from each and every point of that stability. It is more important than fault calculations, my dear friends. Okay, so please do understand what is meant by steady state stability right now. Listen, first we will discuss steady state stability with respect to ideal case, then we will discuss steady state stability with respect to practical case, my dear friends. Tell me, what is ideal case? Synchronous generator. Ideal case is synchronous generator directly connected to load. That means entire India is connected to synchronous generator directly. That means directly synchronous generator is connected to each and every home. Practically it is not possible. This is only ideal discussion, my dear friends. That means to understand practical scenario or practical situation, we have to understand first ideal case. That means based on ideal case we can compare with practical results, so that we can understand power system more effectively, my dear friends. Now tell me, ideal case I am discussing. What is the input power to the synchronous generator? Is going to be shaft power. Output power at the load point is going to be electrical power. Just now I have explained, my dear friends, the angle at the synchronous generator is going to be delta. This is going to be angle between reference rotating axis to the rotor rotating axis, my dear friends. And internal voltage of synchronous generator is represented by E, and angle is going to be delta, and voltage of the inductive load is going to be V, and angle is going to be 0. Just now I have explained, my dear engineers, always angle of the generator must be more than angle at the load point, then only power can flow from generator to the load point because of inductive load, my dear friends. Am I correct? Now all these values are going to be represented in per unit. Now don't ask any doubt. Please do not ask any doubt here related to per unit representation. Among all, the best representation is going to be per unit representation. I hope everybody remembered the per unit discussions, my dear friends. That is going to be useful right now in the stability class. Not only stability, entire power system per unit is going to be useful, my dear friends. Among all, the best representation is per unit representation, my dear friends. The current which is delivered by the synchronous generator, I am assuming it is going to be I per unit. We know, engineers, the impedance of the synchronous generator windings is nothing but Z is equal to R plus Jx, but winding size is going to be larger in case of power system. Therefore, when winding size is larger, resistance is much negligible compared to inductive reactance. Therefore, impedance is equal to reactance of the synchronous generator, my dear friends. Am I correct? This is very, very important. Tell me, everybody understood or not? And also we have discussed in basic class, generator is going to be star connected with resistance grounding, but not going to be reactance grounding, but not going to be solid grounding, but not going to be isolated grounding. Why generator is going to be always star with resistance grounding? We will finish at end of the stability class, not today. At end of the syllabus of stability, we will finish. Why? Resistance grounding is going to be more dominated in practical power system rather than reactance grounding or solid grounding or isolated grounding, my dear friends. This is going to be the ideal case, my dear friends. Now question is, the steady state stability of a synchronous generator, the steady state stability of a synchronous generator can be calculated by using real power transfer equations, from in between generator to the load point, assuming that the generator is going to be star connected equal, that means three phase star connected winding with resistance grounding, and also we are assuming all the three phases are under idea, that means identical. Then we are representing per phase per unit representation, my dear friends. From per unit representation we are understanding itself, we are going to represent any three phase system by per unit representation and per phase manner. Why? Because all the three phases are identical in design. Once again I am repeating, the steady state stability of ideal case of synchronous generator can be calculated by calculating power transfer equation from generator to the load point by assuming that synchronous generator is going to be star connected with resistance grounding and all the three phases in star connected are identical. Therefore, we are going to calculate the power transfer equation with respect to per phase manner and per unit representation, my dear friends. Now most important thing is, what is stability definition? It is ability of generator which could able to deliver maximum real power. Therefore, the stability concept is always discussed with respect to real power flow but not going to be other power flows. Am I correct? Therefore, we need to develop simulation diagram for this. Tell me, what is the simulation diagram? Simulation diagram of synchronous generator is a source. Therefore, it is a voltage source. Voltage source is represented by a source in series with the internal reactance. Reference is going to be neutral, my dear friends. Reference is going to be what? Neutral. Reference is going to be neutral, my dear friends, for all the three phases, and induced EMF is going to be E at an angle delta. It is E per unit, and current delivered by synchronous generator is I per unit. Reactance of the synchronous generator is going to be Jx, and we have to calculate power system stability with respect to load. Therefore, at the load point the voltage is going to be V at an angle 0. This is going to be the simulation diagram in per phase per unit representation. Am I correct, my dear friends? Now tell me, my dear friends, how to calculate stability with respect to ideal case? By calculating real power flow equations. In order to calculate real power flow equations, first we need to develop complex power flow, that is total power flow. Tell me, S is equal to, what is the formula? V into I conjugate at the receiving end. Stability is calculating with respect to the load because variations at the load point. Therefore, S is equal to V into I conjugate. What is the necessity of conjugate with respect to current? The conjugate always can explain proper sign for reactive power. That is the reason why we have to use conjugate for current. Dear friend, resistor is going to be always positive sign, and reactive power is going to be positive or negative because reactive power is dealing with two elements in the line, that is inductor and capacitor, but resistor is always dealing with real power, my dear friends. I can say reactive power always we have to calculate whether it is positive sign or negative sign because two elements are dealing with the reactive power. That is the reason why to get proper sign for reactive power, conjugate is necessary, my dear friends. Okay. Manishankar, best teacher in my life. Really, thank you, my dear friend. Thank you so much for your respect towards me. But still, I want to prove, because if you are enjoying solving questions in power system in GATE and IES or any PSUs or any kind of exam without any mistakes, at the time your statement is going to be perfectly suitable for me. Up to the time I have to do hard work, my dear friends. Okay, up to the time I have to do hard work. So please stay tuned and enjoy the power system up to ending with the patience. Automatically you are able to solve any kind of question in any kind of exam, my dear friends. Okay, listen. S is equal to V into I conjugate. Now S is nothing but complex power or total power or apparent power, my dear friends. Now tell me, S is equal to what? V at an angle, V is nothing but V at an angle 0 degrees. I, current I can be calculated as KVL or Ohm's law. Tell me, it is going to be E at an angle delta minus V at an angle 0 divided by impedance, that is Jx whole conjugate. But what is the angle of J, my dear friends? In order to reduce the steps, I am going to write it as by Jx, I am writing it as x at an angle 90 degrees, because angle of J is going to be 90 degrees. I need to reduce the number of steps, that's the reason why Jx I written directly by x at an angle 90 degrees. Okay, do the calculations, my dear friends. S is equal to V at an angle 0 multiplied by E divided by x, but engineers, I am going to reduce the number of steps here. When two angles are divided, result will be subtraction, that is delta by 90 will be written as delta minus 90, but after removing the conjugate, the angle is going to be reversed, that is 90 minus delta. Please respond, my dear friends. Everybody understanding concept here? Actually angle is delta minus 90 with whole conjugate. Remove the conjugate, then angle will be reversed, that is 90 minus delta minus V divided by reactance is going to be x. 0 divided by 90 degrees will be minus 90 degrees. By removing the conjugate, it is going to be plus 90 degrees, my dear friends. That means I removed the conjugate because I adjusted everything. Tell me, everybody understood these points or not? Please respond. Now S is equal to E into V, multiply this voltage internally, E into V divided by X, angle is going to be 90 minus delta minus V into V is going to be V square divided by reactance X, angle is going to be plus 90. This is going to be total complex power of the load point. That means the complex power I have calculated at the load point, my dear friends. Okay. Now tell me that complex power can be represented by P plus JQ. Already in the basics itself I have explained, my dear friends. Whenever you take a conjugate for current, first two classes I have explained. I think third video of YouTube GATE Academy global channel playlist, third video, that means I have uploaded many playlist videos are there. In the third video I have explained, for inductive load, whenever you given conjugate for current, inductive load is going to be represented by P plus JQ, my dear friends. It is going to be P plus JQ. Now tell me how to get P, that is P is nothing but useful power or real power. How to calculate P? Just multiply these angles with cos, you will get the real power. Now tell me, real power is equal to E into V divided by X cos 90 minus delta minus V square divided by X cos 90, my dear friends. Tell me, cos 90 is going to be 0, cos 90 minus delta is going to be sin delta. Now tell me, the active power or electrical power or output power or useful power at the load point is E into V divided by X cos 90 minus delta is going to be sin delta. This is going to be the real power at the load point under ideal case, my dear friends. Very important. Many times the questions asked from this formula, dear friends. This is going to be very much important, my dear friends. Real power always multiplying by cos, reactive power is always multiplying by sin. That is the basic mathematical fundamentals. I think what I can say, in basic level, 6th to 7th class level, we have studied all these things. Maybe you forget it these days. That is the reason why real power is always associated with cos angle, and reactive value, imaginary value, is always associated with sin angle. That is a basic level discussion. If any time permits, I will explain these points at one particular time. Right now, can we move forward direction? I think Lakshmi, you got the point here. Okay, listen. Dear friends, this is going to be 3-phase power or single phase power. Can anybody give the answer? This is the 3-phase useful power or single phase useful power at the load point. I required answers from each and everybody. This is very, very important. I required, chat box is very empty, my dear friends. I required answers from each and everybody. Aditya Kumar, sir, we are not taking about fault, then it is instability. Why do you ignore line resistance? Very good question. Aditya Kumar, it is resistance ignoring in power system is not depends on the fault calculations. Resistance we are ignoring in the power system calculations because of machines are winding. Machine winding is going to be larger in size. When machine winding is going to be larger in size, area of cross section of the windings is going to be very much high. Automatically resistance is going to be negligible, Aditya Kumar. That is the reason why we are ignoring resistance calculations in case of power system subject. But in the power system, one more topic is there, that is called distribution system. In distribution system, resistance is considered. Why? Because area of cross section of the windings in case of distribution lines is going to be very much less. When area less, resistance is going to be more. That is a simple concept. Okay. This is the problem. See, every person is replied is going to be single phase power. No doubt, my dear friends, that is perfectly wrong answer. It is going to be 3-phase power, my dear friends. It is by default, my dear friends, already have explained. The calculation of power is going to be 3-phase power. We are analyzing per phase analysis, but power, whatever we have calculated is always by default, it is going to be 3-phase power, my dear friends. Per unit per phase. The diagram is per unit per phase, but it is going to be 3-phase power, my dear friends. And the voltage E and V, this E and V is going to be, whenever you taken it as 3-phase power, E and V are line to line voltage in kilovolts. Line to line voltage in kilovolts. In case of actual. And X is going to be transfer reactance but not driving point reactance. X is going to be transfer reactance in per phase but not going to be driving point reactance. The driving point reactance calculations we have studied in case of fault calculations, my dear friends. Driving point reactance calculations we have studied at fault calculations, because with respect to fault you are calculating each and everything, my dear friends. But in the power system stability, we are discussing stability from generator to the load point. Dear friends, always the power calculations is going to be 3-phase. Please do understand these points. Many times I am repeating this point. Okay. Aditya Kumar did not understand. Okay, I will come to this basic level at one time, but do understand the power calculations are always going to be 3-phase power calculations. And dear friends, power system stability is discussing from generator to the load. Therefore, we need to discuss complete reactance from the generator to the load. Therefore, generator to load, generator is going to be one node and load is going to be another node. The between two nodes or 2 points we are calculating the reactance, my dear friends. Therefore, the X is going to be called as transfer reactance, and this is going to be 3-phase real power equation, and E and V are going to be line to line voltages, my dear friends. Okay, let us move forward direction. Reactive power Q is equal to multiply above total power equation with the sign. So, reactive power Q is equal to E into V divided by X sin 90 minus delta minus V square by X sin 90. This is going to be the reactive power equation or wattless power. Now, Q is equal to E into V divided by X sin 90 minus delta is going to be cos delta and minus V square by X, where E and V are the voltages of line to line and Q is going to be reactive power of 3-phase and X is going to be transfer reactance from generator to the load point, my dear friends. It is going to be transfer reactance from generator to the load point, my dear friends. This is very, very important. Please do understand. This is going to be the reactive power equation, and above is going to be real power equation. Many times these questions based on these formulas, many gate questions are came based on these two formulas. If you are following each and every day of my class, there is no chance you can lose single question in the power system. You can kill each and every question in case of power system, my dear friends. What a tremendous explanation, sir. Thank you, YSK. Okay, let us move forward direction, my dear friends. This is the reactive power equation at the load point, and this is the real power equation at the load point. At least tell me, my dear engineers, this real power and reactive power equations we have calculated with respect to the load point or with respect to the source point. Please give me the answers. Please give me the answers. Without asking questions, you will not become more powerful. If I am asking questions, you will become more active. Automatically, my dear friends, you can kill the power system. Without questions is like one-way traffic. With questions, it is going to be two-way traffic. Two-way traffic means more attention is going to be there. Very good. Very good, my dear friends. Srinath is replied, Ashwini Kumar replied, Karthik is replied, Mayura is Mayura, oh my god, Mayur, once again, see, that is a problem here. So to get the answers from you, just I am asking, I am checking you guys. See, dear friends, I am calculating the total power with respect to the load point. See, total power S is equal to V into I conjugate. That means with respect to load point, I have calculated all these power flow equations. Very, very important, my dear friends. Only Mayura, please correct your answer. Remaining people are given correct answer. No problem. Without mistakes, nobody can become perfect. Mistakes are accepted, but not repeat that mistakes. That is going to be simple suggestion, my dear friends. Tell me, the real power and reactive power, whatever we have calculated in ideal case, is with respect to the load point or with respect to the source point, is going to be calculated at the load point. Why? Because V is going to be the load voltage and I is the current which is reaches to the load point. Now tell me, X is going to be transfer reactance or driving point reactance? Give the answers, give the answers. X, the reactance is going to be transfer reactance or driving point reactance? Give me the answers. Give me the answers. Give me the answers. Transfer reactance calculations will be performed in between from one point to another point, that is in case of stability topic, whereas driving point reactance calculating with respect to same node, we are calculating driving point reactance, that is in case of fault calculation. That means in case of positive sequence, negative sequence, zero sequence reactance calculations of symmetrical components and fault calculations, we have completed driving point reactances. But in power system stability, the reactance is going to be completely transfer reactance, my dear friends. The transfer reactance is between 2 points. One is source, other is going to be load, my dear friends. Tell me, everybody understood the concept? Very good. No mistake from each and every person is replied powerfully. Transfer, transfer, transfer. Means you are transferring something to me. Very good. Now listen, we need to discuss what is stability definition. It is ability of synchronous generator which could able to deliver maximum useful power or real power to the load point by maintaining synchronization with externally connected transmission lines is known as stability. What is steady state stability definition? Steady state stability definition is, it is ability of synchronous generator which could able to deliver maximum real power to the load point by maintaining synchronization with externally connected transmission lines when load is under small and gradual variation of load. This condition, if you include, the definition is going to be steady state stability. Now tell me, what is steady state stability definition, my dear friends? It is ability of synchronous generator which could able to deliver maximum real power to the load point by maintaining synchronization with externally connected transmission lines when load is under small and gradual variation of load is known as steady state stability limit. What is steady state stability limit of our class is, it is ability of the Vishnu Sir or ability of the power system faculty could able to deliver maximum useful content to the students by maintaining synchronization with entire this sectional setup, provided that there is a small and gradual variation of load is known as steady state stability. Tell me, in our classroom, the variations present at the load side or source side? Load side, student side. Means don't think that I am great, you are not like great. I am not saying that. Generally in the offline classes, small discussions between the students, that is going to be small and gradual variation of load. whenever like girlfriend and boyfriend is sitting by side in the offline class, when the small discussion is happening, when class is going seriously from the faculty side, that small discussion is not disturbing all the people in the class, right? That is going to be steady state stability. At the time also I am maintaining stability in my discussion, that is called under steady state stability, my dear friends. What is transient stability? Is if there is a sudden large variations is occurred in the classroom, maybe some fight or something is happened, at the time also I am maintaining synchronism with respect to all the students, that is going to be transient stability, my dear friends. Okay, now this is going to be power transfer calculations in ideal case. Now we have to discuss real power equation. Listen, real power equation PE is equal to E into V divided by X into sine delta. Tell me, when load is going to be varies, please give me the answers. When load is going to be varies, internal voltage is almost constant, voltage of the load also constant, reactance, transfer reactance also constant, that means E is constant, V is constant, X is constant. When load is variable, almost all these three parameters are constant. When load is going to be varies, suddenly load angle delta also going to be varies. When load angle delta varies, automatically real power also going to be varies, my dear friends. That means variations of real power or variations of electrical power is because of variations of load angle. Why load angle delta is variable? When there is a variations at the load point, my dear friends. Am I correct? That means real power completely depends on load angle delta. Therefore, we need to draw the power angle curve or load angle curve, because the real power variation is with respect to delta, my dear friends. The real power variations or electrical power or active power variations with respect to delta. Now tell me friends, which is going to be independent, which is going to be dependent? Delta is going to be independent, that is going to be represented in x-axis, and electrical power is going to be dependent on delta, that is going to be represented on y-axis, my dear friends. YSK, sir, what is the driving and transfer reactances? Simple YSK, listen. Let us assume this is the single line diagram. Fault occurs at this point. When fault occurs at this point, synchronous generator is delivering current to the fault point because this is low impedance. Then we are going to calculate reactance with respect to fault point, like this. We are opening the terminals at the fault point by using Thevenin's theorem. We are measuring reactance between these 2 points. That means reactance is calculating with respect to this bus bar. This is going to be driving point reactance. Let us assume same discussion. There is no fault. Let us assume it is the load point or infinite bus. Now if you calculate the reactance, this is going to be source and this is going to be load. If you calculate the reactance between source to load, that means including generator, including transformer, including line, the reactance whatever you are calculating between source and node is going to be transfer reactance. Source is one point, load is another different point. If you are calculating reactance between two different points, that is called as transfer reactance. If you are calculating reactance with respect to same node, that is called as driving point reactance. This is very important, that already I have explained. In case of fault calculations, I have clearly explained. Tell me, YSK, is your doubt is cleared or not? Respond once. What about remaining friends? Everybody understand what is the driving point reactance and transfer reactance or transfer impedance? Response is compulsory, my dear friends. Time is approaching, please tell me. Time is approaching, please tell me. Everybody understand the concept or not? Okay. Calculating reactance with respect to same node is driving point. Calculating reactance between one point to another point is called as transfer reactance. That's it. Listen. Dear friends, real power is going to be varies with respect to delta, my dear friends. Let us assume delta initially I will be starting with 0 degrees. When delta equal to 0 degrees, real power is going to be 0. Sin 0, 0. No doubt that at the time no power is delivered to the load point, my dear friends. When delta equal to 45 degrees, real power, electrical power is going to be, sin 45 is 1 by root 2, which is 0.707. 0.707 multiplied by EB by X. That means electrical power is going to be 70.7% of EB by X. I can say when delta is going to be 90 degrees, electrical power is going to be sin 90 is going to be 1, which is going to be maximum. I can say this is going to be EB by X. Now tell me friends, delta equal to 90 degrees, electrical power become maximum, that is nothing but EB by X. I can say at delta equal to 90 degrees, electrical power is also called as maximum power. This is very very important, please do understand. At delta equal to 90 degrees, electrical power become maximum power, where that maximum power formula is going to be EB by X. What is the meaning of maximum power is? It is the ability of synchronous generator which can deliver this much amount of power to the load point without loss of any synchronism or without losing of any stability. This much amount of power is generated, that means generating by the generator and also delivering to the load point without loss of any synchronism. Once again I am repeating, what is maximum power definition is? It is the amount of power that can be delivered by synchronous generator to the load point without loss of any synchronism. Tell me how much amount of power it is delivering to the load point without loss of synchronism is going to be EB by X. Now dear friends, when delta equal to 135 degrees, electrical power P is becoming, tell me sin 135, sin 90 plus 45, which is going to be cos 45, cos 45 is going to be same, 0.707 is EB by X. Now tell me friends, now tell me when delta is increased beyond 90 degrees, electrical power starts reducing, transferring from generator to the load. Previously it is EB by X, now it is going to be 0.707 EB by X. Now tell me when delta becomes 180 degrees, my dear friends, the electrical power is going to be sin 180 is going to be 0. That means the electrical power delivered by the synchronous generator to the load point, electrical power delivered by the synchronous generator to the load point is going to be 0. That means we need to draw the curve right now. Listen, when delta equal to 0 degrees, delta is 0 degrees means it is going to be at origin, and electrical power is also going to be 0. That means x-axis value 0, y-axis value is 0. When delta is going to be 45 degrees, my dear friends, and correspondingly electrical power is going to be increased from 0 to 0.707 pm, means maximum power, where maximum power is going to be EB by X. Now tell me when delta is equal to 90 degrees, this is going to be reaches to maximum power. Maximum power is nothing but EB by X, my dear friends. Wherever E into V divided by X is there, that is going to be maximum power, my dear friends. That is going to be called as maximum power. Now tell me when delta is equal to 90 degrees, that is going to be reaches to maximum power. I can say is look like a sinusoidal waveform. Which waveform? Sinusoidal waveform. Tell me at delta equal to 90 degrees, power is going to be maximum, my dear friends. Listen, at delta equal to 45 degrees, the power is going to be 0.707 pm. When delta equal to 90 degrees, my dear friends, the power is going to be maximum. This maximum power formula is going to be EB by X. It is the amount of power, that means this point is called as maximum power, is also called as steady state stability limit. This is also called as steady state stability limit. It can be written as SSSL or S cubed L, where S cubed is steady state stability limit. That maximum power is also called as steady state stability limit, my dear friends. Now tell me, when delta is increasing from 0 to 90 degrees, when delta is increasing from 0 to 90 degrees, the electrical power delivered by the synchronous generator also increased or going to be decreased or remains constant, is increased. Therefore, this region is called as stable region. This region is called as what? Stable region, my dear friends. Now tell me, stable region is going to be 0 less than delta less than 90 degrees. Now this 90 degrees point is called as steady state stability limit or S cubed L, or is going to be maximum power, my dear friends, where maximum power definition is it is ability of the synchronous generator, that much amount of power can be delivered to the load point without loss of any synchronism. Now tell me, dear friends, I want to discuss one important point here is, when delta is increasing beyond 90 degrees, when delta is becoming 135 degrees, my dear friends, corresponding value is going to be 0.707. That means when delta is increased on x-axis, but on y-axis value is going to be reduced from maximum power to 0.707 and delta becomes 180 degrees, my dear friends, the electrical power is going to be 0. That means electrical power delivered by synchronous generator is going to be 0. Therefore, this is going to be unstable region. That means something happened to the synchronous generator when angle is going to be increased beyond 90 degrees. Something happened to the synchronous generator when angle is increased beyond 90 degrees, my dear friends. Now tell me, when delta is increasing from 0 to 90 degrees, the generator is generating more power and it transmitting to the load point in increasing manner, and it is reaches to maximum at delta equal to 90 degrees. When delta is increasing beyond 90 degrees, which results angle increases but maximum power delivered to the load point decreases, I can say the synchronous generator is going to be unstable region when delta is going to be more than 90 degrees. Now tell me, this is going to be 90 less than delta less than 180 degrees is going to be the unstable region, and this is going to be a stable region. These characteristics we need to study in terms of magnetic flux characteristics between stator and rotor fielding winding of synchronous generator, that is called as electrical stiffness or synchronizing power coefficient, my dear friends. That means what happened exactly internally, what is happening to the generator. That means I said when delta is in between 0 to 90, generator is going to be more stable because it is generating more power and also transmitting maximum power. When delta is increasing beyond 90, generator is going to be transmitting less power to the load point. That means the power delivering to the load point is decreasing when delta increases beyond 90 degrees. That means something happened to synchronous generator. Something happened to synchronous generator that we have to understand internally in the synchronous generator, that internally which is present, stator and rotor field winding is present. Therefore, what happens to synchronous generator after 90 degrees, that we have to understand by studying magnetic flux characteristics of the stator and rotor field windings, which is going to be called as, that magnetic flux characteristics between stator and rotor field winding is going to be called as synchronizing power coefficient or electrical stiffness, that I am going to be discussed tomorrow class, my dear friends. That swinging or what, that is going to be discussed tomorrow class, my dear friends. Tell me, up to now everybody got the concept right now? Up to now everybody got the concept or not? Please respond, my dear engineers. Please respond. Really thank you, my dear friends. Love you guys. You are going to be powerful. My dear friends, with respect to power system. Tanjeem, sir, please give your Telegram channel link. I will give the Telegram channel link. Tanjeem, I am going to post my Telegram channel link tomorrow because I have to copy from my WhatsApp, then I will post it. Okay, tomorrow I am going to post my Telegram link, my dear friends. If anybody have Telegram link of mine, please share so that the maximum people can understand. Okay, maximum people can join. Okay, very good, my dear friends. Thank you for your tremendous response. But you are doing really a great job for me. Really, I am very much thankful each and every of my dear Priya Vidyarthiyo, Priya dear students, that you are sharing my information to many groups so that many new students are coming. But still, I am expecting more from you. It is really difficult task really to you. Please share as much as possible our content and our information in all your groups and all in your accounts so that maximum people can enjoy our power system so that they can settle in their life. That is going to be more happiest thing to me. Okay, sir, are you Telugu? Avunu, nenu Teluge. I am from Andhra Pradesh, near to Tirupati, Lord Bhagavan Venkateshwara Swami. Near to Tirupati, I am very Sabka Malik Ek Hai. Okay, Ashwini Kumar, no sir, you are doing more for us. Thank you, Ashwini Kumar, but still I need to do more. Suresh, thank you. YSK, thank you. Everybody, Aditya Kumar, Srinath, Tanjeem, Ashwini Kumar, Satish, everybody, thank you. Powerful concepts come from powerful men. Thank you, Karthik. Srinath, I am from Kadapa, sir. I am also from Kadapa. I am from Raichoti, nearer to Kadapa district. But no matter, we are Indians, we will enjoy the subject. Okay? We are Indians, we will enjoy the subject, my dear friends. Oh, Tanjeem Khanham, I am also from Kadapa. Very good, very good. So, nice friends, nice to see all of you. Very good, very good. Tomorrow, my dear friends, at 6 p.m. Don't forget, please put reminder on and also share our content as much as possible in FB, Facebook, Telegram, Instagram, LinkedIn and entire social media. Utilize positively my content, not negatively, my dear friends, so that maximum people I can see in tomorrow class will enjoy more, my dear friends. Okay, thank you, bye bye, love you, my dear friends, good night, see you tomorrow evening 6 p.m. Don't forget to put the reminder on. Thank you, my dear friends, good night, bye bye, love you guys, bye.